Hello everyone. Myself Dr. Preeti, Skill Assistant Professor, Electrical Engineering from Shri Vishwakarma Skill University, is going to teach you the first course on Basics of Electrical and Electronics Engineering. In this particular course, we are going to cover 5 modules. The first module would be focusing on the DC circuits. Second module would be covering the 3-phase AC circuits. Third module will be focusing on electrical machines. The fourth module is focusing on protective devices and the safety precautions in electrical engineering. And fifth unit, that would be focusing upon the basic semiconductor devices and their applications. When we are talking about the learning outcomes of this particular course, the main outcomes after the understanding and covering the particular content of this particular course are: number 1, for module 1, you will be able to understand the concepts of voltage, current and power and the DC circuit analysis. When we are talking about the AC circuits, that is the second module, the outcome would be you will be able to understand the concepts of AC circuits and its analysis part. Regarding the third module, that is focusing on electrical machines, the outcome you will be able to understand the concept of electrical motors, generators, transformers and their applications. Safety precautions and the outcome of the fourth module, that is protective devices and safety precautions, would be you will be able to understand the various working of protective devices, example relay and circuit breaker. Semiconductor devices and their applications would be covered in the fifth module, and after covering the content for the fifth module, you will be able to understand their applications, their characteristics and their various implementations in the electronic circuits. The various textbooks and the reference books are given on the screen for your reference for this particular course. Let's start with the first module, that is the DC circuits. So, with the introduction of the DC circuits, and in this particular session we would be covering the content, that is number 1, definition and units of current, definition and unit of charge, voltage, concept of resistance, conductance, power, inductance and capacitance. So, what do you mean by meter? Let's start us with the introduction for the concepts of charge and the electric current. Basically, we need to understand what is the electron. Before starting the concept of electrons, we should understand what is the matter and where comes the electrons and the positively charged particles. What is the matter? Anything that occupies the space and has weight, right? So, accordingly and generally, we are dividing the matter into 3 states, that is solid, liquid, gas. Anything that is around here, your clothes, books, air, water is a type of matter. Then the matter is further classified into the element. What is the element? That is basic building block of nature. That is, element is the basic building block of nature. Further, it is to be clarified that element cannot be further reduced to any simpler substance by the chemical means. So, what may be the example of element? It may be the gold, silver, oxygen, potassium, etc. Element and the next component would be the compound. So, chemical combination of 2 or more elements is known as the compound. Example of any compound? Yes, water. Water is a combination of hydrogen and oxygen, where hydrogen and oxygen are the 2 elements. Next would be the salt, that is the sodium chloride. Sodium and chlorine would be the 2 elements, and the combination of these 2 elements, that is sodium chloride, forms a compound. Regarding the molecules, we should understand basically the difference between molecule, mixture and atom. Molecule is the smallest part of the compound that still remains the properties of the compound. That still molecule, what is molecule? That is smallest part of compound that still retains the properties of compound. What is mixture? any physical combination of elements and compounds. There is no chemical reaction between the elements or the compounds. Then we come under the category of atoms. What is atom? Smallest particle of an element that retains the characteristics of the element. Let's discuss about the atom. Atom is basically divided into 4 parts. The first part is the nucleus. Second part is the protons. Third part is divided into the neutrons, and fourth is the electrons. What do you mean by nucleus? Nucleus is located at the center of the atom. Then we talk about the protons. What are the protons? The positively charged particles are considered to be as the protons. Then neutrons. Is there any charge on the neutrons? No. The neutral particles, that is the uncharged particles, are known as the neutrons. But when we are talking about the electrons are the negatively charged particles, and also it is to be emphasized that process of gaining the electrons or losing the electrons is known as the ionization. This is the electrons that are lost from the atom or they are gained for the atom in the valence shell, and this process is known as the ionization. Basically, the content that we have covered up to till now, the question and answers, a brief quick review what we have gone through is on your screen to reflect upon. I hope that you might have been understood the idea and the differences between the various terminologies related to the elements, compounds, atom, molecules, and in this particular manner we can proceed to our next topic, that is the electrical circuit, right. So when we are talking about the electrical engineering, we oftenly interested in communication and the transferring energy from one point to another point. So how this particular energy is being transferred? This is the interesting one, right? So in particularly we are termed name as the electrical circuit, which is the interconnection of the electrical elements. As given on the screen, you can see the circuit is basically comprising of 3 elements: the switch, battery, and the key product, right. So the element, when you are talking about the interconnection of electrical element, this means the current and the electrons will flow through the circuit only when it will be in a closed circuit. First we will talk about the electrical charge. What is electrical charge? It is the basic quantity of an electrical circuit. So previously we discussed about the various charged particles. The charged particles were protons, neutrons, and electrons, where protons was positively charged, neutron was uncharged particle, and electron was having the negatively charged particle. When we are talking about the electrical property of atomic particles, of which the matter consists of, then here comes the charge. So what is the unit of charge? That is coulombs, because, and it is denoted by capital C. The charge on an electron is given by minus 1.602 multiplied by 10 raised to power minus 19 coulomb. Proton carries the positive charge, electron carries the negative charge. So if you are talking about the charge on an one electron, so it will be minus 1.602 multiplied by 10 raised to power minus 19 coulomb. And when we are talking about the positive, so this minus sign will be positive, right. So you must have heard about the law of conservation. So in electrical engineering, we have the law of conservation of charge. What is charge? That is, can neither be created and nor be destroyed. So by this time you might have a basic idea of the electrical charge. Now we will be proceeding for the next topic, that is the current. What is current? The current is the flow of electrons in a closed circuit. Flow of electrons, when you are talking about, that is from one point to another point, the movement of electrons is known as the current, that is the electric current. Or alternatively, this can also be defined as time rate of charge. So we can write it as current, that is capital I, is equals to charge, that is represented by Q divided by time. So the unit of the current is amperes, and when we are talking about ampere, when we would be saying that this is a charge, this is a electric current, that 1 ampere of current is flowing. When 1 coulomb of charge moves a single point in 1 second. So that is the definition of 1 ampere, and when 1 coulomb of charge is moved through a single point in 1 second, then we will say that 1 ampere of current would be flowing through the circuit. Now current we can classify into the two categories, that is number 1 direct current, second one would be the alternating current. Direct current, what is direct current? Question arises, we always be hearing about the two terminologies, AC and DC. The abbreviation of DC is the direct current, abbreviation of the AC is alternating current. How comes the DC? And what would be the differences between AC and DC? So let's discuss. DC is the direct current, it means direct value. So it always flow in one direction, or a single polarity is there. If a current is having single polarity or the voltage is having single polarity, that particular electrical quantity is known as the direct current value or the DC voltage value, right? Also, when I am saying that it is having a single polarity, so this also implies that this does not reverses the direction. In contrary to this, alternating current changes its direction or polarity at every instant of time. At every instant of time, the magnitude of the alternating current is changing. When the positive polarity is there for the half cycle, and during the next half cycle it will be the negative half cycle. So let's draw this particular waveforms, how we can represent the AC and DC. In the DC format, when you will be having the voltage and you will be having the time across the x-axis, or voltage or the current across the y-axis, then you can see in the waveform that a direct current, a constant value is shown for the voltage or the current. Alternatively, for the AC current or the AC voltage value, we will be seeing that a sinusoidal wave example is the best one for the alternating current representation. Let us say from angle 0 to pi, you will be having positive polarity. From pi to 2 pi, you will be having negative polarity. So we can see that every instant of time, the magnitude is changing, and over after a half cycle period, then the polarity is changing. So in one cycle of alternating current voltage or current, so we have both polarities, positive as well as negative. In generally and in domestic applications, in India we use the alternating current value, whereas in electronics items, for example phones, laptops, batteries charging, where we are using, all such applications are the use of direct current, that is a DC. So DC is used to store, whereas it is very much difficult to store the alternating current value. Let's move forward to our next topic, that is a voltage. What do you mean by voltage? Any energy required to move a unit charge. We have already discussed that is the flow of electrons is known as the current, right? So how these electrons are flowing? So to move and to get flow the electrons, the energy is required. So energy required to move the electrons from one point to another point, that particular electrical pressure is known as the voltage. This voltage is also known as the electromotive force or the potential difference, because when one point is at higher potential and another point has lower potential, then the electrons will be flowing from higher potential to the lower potential point. So this particular range results into the potential difference of electrons flow, and the voltage results into the current. Generally, symbol capital E is used to represent the voltage, or alternatively we can also use capital V. So, with this we will summarize the concepts of electrical charge, electrical current and electrical voltage. What is electrical charge? What is electrical charge? That is a basic quantity of the electrical circuit, and it is the electrical property of the charged particle or the atomic particle of which the matter consists of. Next, that is the electric current. It is the flow of electrons from one point to another point of the electrical circuit is known as the electrical current. Electric current is classified into two types, AC quantity and DC quantity. Voltage. Voltage is the electrical energy required to move a unit charge from one reference point to another point. The units of charge is coulomb, unit of current is ampere and unit of voltage is volts. A quick recap we have done till now. Now let us move forward with the question and answer, and so that you will be able to revise what we have done till now. The first question, that would be the how much charge is represented by 4600 electrons. Are you able to do that? What is the term used to describe the opposition to electrical current flow? How you will define the electrical voltage? Then, who invented the first cell to produce electricity? What force moves the electrons in an electrical circuit? In next part, we are moving towards the next topic, that is resistance. What do you mean by resistance? That is opposition to the electric current is known as the resistance. So, as you can see in the figure that voltage is trying to push the man out of this particular hole, and we can represent the man trying to move from one point to another point as current, the man who is trying to push the current as voltage. However, what is the value? What is the result? The resistance, the man in the green shirt is trying to oppose the current and is binding him not to go from one point to another point. This is a very much popular analogy to understand the concept of voltage, current and resistance. So, the resistance is basically opposition to flow of electrons. Degree of resistance of a material completely depending upon its size, shape, dimensions and temperature of the surroundings as well. The various parameters that are affecting the resistances are its size, shape and temperature of the surroundings. Depending upon the resistance, the materials are generally classified into the three categories. Number one, that is conductors. Second, insulators. Third is semiconductors. Let us discuss about conductors. What will be the value of conductors? Resistance. The materials that are having minimum resistances or the low resistances are classified to be as the conductors. For example, gold, aluminium, copper, etc. When we are talking about the insulators, they are having the materials which are possessing very high value of resistance. When you are talking about the high value of resistance, it implies that it will not allow to flow the current across them. We can name the insulators to be plastic, wood, etc. When we are talking about the semiconductors, so the resistance lies in between the conductors and the insulators. For example, silicon, germanium, etc. The unit of resistance is measured in ohms. Now, what is conductance? When we are talking about resistance is stopping the current to flow, then the conductance is opposite of the resistance. So, it defines the ability of a material to pass the electrons. It means to flow the current through the electrical wire or the circuit. This is a reciprocal of resistance and hence its unit is also mho, that is MHO. It can also be represented by R is equals to 1 upon G, where R is the resistance of material and G is the conductance of material. Let us proceed with the resistor identification. As you can see on the figure that we are having a 4-band resistor on the resistor. Let us proceed with the resistor identification. How we can identify the resistor? Let us first go with the 4-band resistor. The first band will be denoting your first digit of the resistor. Second band will be also denoting your second digit. Third band will imply your multiplication factor, and fourth digit will be giving your tolerance limit. Either it is gold or the silver or no color it is there. So it will show, the fourth band will show the tolerance limit. Let us proceed with the example. You can see on the slide that we are having 4 colors on the band of the resistor. Number 1 is brown, second one is green, third one is red, and fourth one is silver. So what is the color for the first band? That is brown, that is 1. What is the digit corresponding to the green color? That is 5. What is the digit corresponding to the red? That is only 00, that is 2 zeros. So the net answer of the resistance would be 1 for brown, green for 5, and red is 2 zeros, that is 1500 ohms. And the fourth band, that is the silver, implies the tolerance limit, right? What will be the tolerance limit against the silver? That is 10%. So 1500 ohms plus minus of 10% would be the answer for this particular resistor. We are also having the resistors where we are having the 5 bands. So what will be the significance of these particular 5 bands and how we can identify their values? The number 1 band would be the first digit of the value. Second band would also be the second digit of the value. Third band would imply your number of zeros, or you can say the multiplication factor. Fourth band would be your tolerance limit, and fifth band would be your reliability of the resistance. Let's stop here for the quick revision and reflection of what we have studied till now. What is the term used to describe opposition of current flow? I hope you all know the answer right now, that is the resistance. What is the main difference between conductors and insulators? This is the difference of resistance. Conductors are having very less resistance, whereas insulators are having high resistance. Which letter is used to represent the resistance? That is capital R. What is the symbol that is used to represent the unit of resistance? That is ohm. What is the unit of resistance? I have already told, yes, this is ohm. So, in this particular session, we have covered the definitions and units of voltage, current, electrical charge and resistance. Thank you very much.